Hello everyone. In this example, we will see how to handle metastable phases, especially in iron-carbon binary system with or without carbon. Although carbon is thermodynamically stable phase than Fe3C, carbon is not appearing in most of low carbon state. Thus, in order to do proper calculations, C should be removed from the compound list, in particularly in steel. So the way shown here, in the same way, if a certain phase is not readily formed or very sluggish to form, we can unselect the phase to simulate the system more realistically. So let's get to it. Now, to make the phase diagram, first we need to open the phase diagram module. So let's just click on the phase diagram module and wait for the window to open. Okay, now since we are going to make iron carbon phase diagram, we are not going to load our previous system, so we are going to just say no. And since our previous system was in it can be anything, we just want to say no to refresh our database selection options. Now we need to select our databases. Since we are going to make iron carbon binary phase diagram, we are going to select FST and select OK. Now, obviously, since it's iron carbon binary diagram, we are just going to add two components, which first one will be iron, second will be carbon. After adding them, we'll select next. Now, let's make the phase diagram with carbon. Let's see what it will show us. So let's just select all the solutions here. Let's select all the solids, and now let's modify our phase diagram. To modify our phase diagram, we need to double click on the variables. So let's just double click anywhere and click next, because if we want a traditional phase diagram, let's click next, and we want our temperature on the y-axis, so we will select y-axis here. We will change the temperature. Let's say temperature is between 500 to 1500 degrees Celsius. Let's keep the pressure constant, and we want the carbon composition to change along the x-axis, so we will select the x-axis. Now we want to add carbon, so we need to switch on the carbon, so we will put 1 here. And you need to remember that this value here is not the actual value. These are just switches, sort of switches. So if 0 means no and 1 means yes, so we want carbon on the x-axis, and we want the composition from 0 to 0.1, let's just say. Now all our setup is done, so we'll click OK and calculate our phase diagram. We'll just click on, and depending on your system, it may take 5 to 10 minutes, so just wait patiently for the system. But here it was pretty fast, so let's get to it. So first we click OK for the default options of these width and height of the phase diagram, so we don't need to change that. Now if you look at the phase diagram here, and let's label all the stable phases. So we have here carbon and FCCA1, we have carbon plus liquid, we have liquid, we have FCC liquid, we have FCCA1, and here we have BCC plus carbon. So let's just save our diagram, and to save our diagram we need to click on the edit button, and we can just simply now save as. Now let's just save somewhere. Let's just save here, and let's call it iron carbon with carbon. Yep, iron carbon with carbon. You can name it any way you want, obviously, and let's just save it. The reason we are saving this is to compare this result to the result we are going to get without carbon. So now we have the result with carbon, but as we have established earlier that C is not appearing in most of low carbon steel. So we need to actually remove the C to simulate the system more realistically. Now to do that, let's get back to our phase diagram module. Here, to do that, since we want to remove carbon, so carbon is a pure solid, so we need to go into the solid section. So to go into the solid section, right click on this selection box. So that will open a new window which will show all the solids present during the calculation. Now we don't want carbon to be present, so we'll just remove the carbon. We'll remove both the carbon and press OK. Now we are forcing the metastable phase to be formed. So now we don't need to change the form of our phase diagram, so we don't need to go into the variable again. We don't need to change any of the solution phases, so we can just directly click on the calculate. So let's just do that and let's wait for the result. I'm hoping it will be fast like previously, and yes, it is. So now, as usual, we are going to click OK for the default option of the width and height of our phase diagram. Now as you can see, this is different. Now let's label all the phases. We have liquid, Fe3C plus liquid, Fe3C plus liquid, and we have FCC plus Fe3C. Now the reason we saved our previous diagram is to superimpose that diagram onto this and to compare them together. So let's just do just that. So for doing that, we need to click on this mode, normal addition mode, and go on this button. This is superimposed figure. So you can click on this. Now you can open the figure which you want to superimpose onto your current figure and click on open. And now you can see the difference between the previous diagram and the new diagram. So previously we had carbon which was thermodynamically more stable phase than Fe3C, but since it was not appearing, we didn't want it inside. So we removed it, and now we have these lines. To make it more clear, we can change the color of the lines. So let's just change it to red and set OK. Okay, here. So it did not change. Oh, sorry. So it should be here. We can select this. Just OK and OK again, and now we have a red color. So this one was the previous line, so we need to change it one by one for each of them. So it became a bit crowded, so let's just remake our remake our diagram once more. Okay, so nope, let's just calculate again. Okay, so the point of superimposing and saving the old diagram was to show you the difference between the stable phase diagram with carbon and metastable phase diagram without carbon. So this one is the metastable phase diagram without carbon. Here we have Fe3C as the metastable phase, and in the previous one we had carbon. So that's how you deal with any phase which is not readily formed or which is sluggish to form, so that Now we can unselect those phases and simulate the system more realistically. Thank you for listening.